Around the same time as Millikan was doing his oil drop experiments, Rutherford decided to test the plum pudding model. That's where we assume that the positive charge is distributed more or less uniformly throughout the atom, and you have small little lumps of negative charge that are sitting there, kind of like the plum or raisins, in some sort of a pudding. Now, in his description, he says that it was like firing a 15-inch shell at a piece of tissue paper. So what he did is he took alpha particles. And alpha particles are going to be one of our heavy particles when we study about radiation. And that's going to be a separate topic altogether. Now, these particles, like I said, are pretty heavy. If we have the plum pudding model true, we're going to see very little deflection, nearly none, as it goes through a very thin piece of gold foil. So they should go straight through with no deflection at all, because all these positive lumps are separated out pretty uniformly in space. So here's the setup that he makes. He puts a bunch of detectors around a radiation source. So we have radiation source. We have a screen here that will flash whenever an alpha particle hits it. And we put a piece of gold foil. That's our tissue paper. Surprisingly enough, though, some of these deflected to the side. He wasn't expecting that a lot, but he said that it would do a little bit. The big, shocking discovery, though, was some of the particles bounced back, right back at the source. And so when we zoom into a very small scale view, we see the incoming alpha particles, many of them going straight through, some are deflecting slightly, and some of them are deflecting almost perfectly back. Now, the best way they could explain that was to say these gold atoms must have a really tiny nucleus with a massive amount of density in it. So all of that positive charge has to be concentrated in a very tiny lump in the center of our atom. It's what we know now as the nucleus, but at the time that flies in the face of the plum pudding model entirely. And it was a major result in understanding how the modern atom is actually designed.